think I told you guys last week or sometime recently that there's an AP exam. There was a FRQ where they actually want you to they want you to actually do like the equations and stuff for like forming ozone and stuff like that. So I got that one for you, just to kind of show you. They haven't had one this, I consider this one difficult in a long time, because it's, I mean, you either know this equation or you don't. That's why I don't like it. So they haven't had one like this in a long time, but I did want to show you that they can, you know, kind of throw something in here like out of left field where it's like, whoa, that's really detailed. And if they do, you know, it's not like that what some of y'all do in this course where you just like look up the answer or whatever. You can't do that during the AP exam, right? So you've got to actually know it. So for some reason this week my pen is not working on the PowerPoint. So I'm gonna use this text box. Can you see this? Does this text box show up? Okay, excellent. I have text written here so many times now. Let me see if I can get rid of those. Okay. Okay, so in this one, basically it says that ozone is an atmospheric trace gas that occurs naturally in the stratosphere. It's also formed as a consequence of human activity in the troposphere, right? So this is what I've tried to talk to a lot of you about. I keep mentioning this. So, right, ozone is in the, it occurs in the stratosphere naturally. That's our ozone layer. And then it's also formed in the troposphere, which is kind of the area where we live, and that is pollution in the troposphere, but it's normal in the stratosphere. So if ozone is in the stratosphere, it's good. I'll put a plus here. And if it's in the troposphere, it's negative, it's bad. And so that's a big thing that students tend to get confused with, is they get confused as to like which type of ozone is good and which type of ozone is bad. So now it's asking about the type of solar radiation that is absorbed by stratospheric ozone, and then it wants to describe a human health benefit. Okay, so for this one, the type of ozone or the type of radiation, you think, let's see, you think that it's, you know, they're like what specifically UV, UVA, UVB, something like that, but really, all you have to do is say ultraviolet to actually get credit. So that's really nice, I think. You can say, wow, so many text boxes. You can say UVA or UVB, but really, as long as you say ultraviolet, they're okay with that. So, and then they want to say like a human health benefit that results from solar energy. So think about it, like if you go out in the sun, what are some bad things that can happen to you if you go out in the sun, right? So bad things are like skin cancer, sunburns, you can damage your eyes, right? That's why we wear sunglasses. So those are bad things, right? Well, they add a benefit from absorbing the solar energy. Oh my goodness, I'm just making text boxes left and right. So all you have to do is you just have to take these bad things and turn them into good things. Okay, and that would be your benefit, right? So you can say, instead of you get skin cancer, you can say lower rates of skin cancer. Okay, or if they say sunburn is something that you can get if you are exposed to solar radiation. So you could say like less sunburn or a lower rate of sunburn. right? Or you could say, like eye damage, you could say a lower rate of eye damage, right? So you just have to take that bad thing and turn it into a good thing, because they say they want a human health benefit instead of a a negative. So that's all you have to do for that kind of part. So that this part is not too bad. You read this and you're like, oh, I got this, right? It's not too bad. Now we get to the second one. Okay, the second one says the absorption of solar energy by stratospheric ozone causes ozone molecules to undergo chemical decomposition and formation. Okay, so if you remember that, that means that we're constantly forming ozone, and it's constantly breaking down. Okay, it's just going back and forth, back and forth. So it says describe the chemical processes that lead to natural balance between ozone or decomposition and the formation of ozone. So you can either use chemical, or you can actually you can type your answer. Okay, and so this is where I think this part is kind of hard, because, like, for example, if I was going to do the equation, right, we have ozone plus UV light equals like O2, which is normal oxygen, plus like an O radical. Basically, this would be like, it's a charged ozone. And then you could write it, let me get a different text box. You could also write it like this. So it looks like, you can write it either way. Oh dear, all these text boxes. I want to actually get back to this one. I just might delete it all. Wow, now I know why I usually write with my pen, right? This is crazy. This is what I meant to write. Okay, so either one of these, right, is a formation reaction, or a decomposition reaction, sorry. Or you could say, like, you could also say ozone absorbs UV radiation, producing oxygen molecule and oxygen atom. Right, so you could write it either way. Jeez, I'm making these text boxes everywhere. So either one of these would be okay, right? So that's the decomposition, and then the formation, you can write is basically the opposite, which is kind of nice, because then you don't have to worry about you really only have to, like, memorize one division. Make sure. Yeah. Okay. So you can write it either way, right? Either one of those would be okay. Either one of those is forming ozone, right? And then you can say that oxygen molecule reacts with oxygen atom to form ozone, or let me see. Will this let me do another? Yeah, cool. Or you can say that oxygen molecule reacts with UV to form ozone. Okay, so you can kind of do it either way. They actually even allow this. And right now I'm just looking at the key, mostly because I want to make sure I get these equations right. I just wanted to show you, the variety of things that they actually allow, but also that, it's kind of detailed what they want. So like instead of doing the two steps, like this step is decomposition. I'll put a D here, and this is the formation. So you can do it in two steps like this. You could also just write it like this, because this would be your decomposition right here, and then this would be your formation here. So you can do it either way. But personally, I find this part of this equation to be really hard, just because you have to memorize those formulas. And then the next one, there's actually a part where they want to memorize. They want you to memorize the formula too, or you at least have to know what the formula means, or like even if you don't memorize the formula, you still need to memorize like what's going on. So I think that part is kind of hard. I like the parts where we can take all of our knowledge that we've learned and then apply it to something. I like that part better. I think those questions are a little bit easier, because there's more answers that could be right. Where in this one, there's a few things they allow, but there's basically like one answer. Now this part is also going to have an equation part I, but also if you notice, the equation part is a small subset of this FRQ. So even if you don't have the equations memorized or whatever, you could still do the FRQ. Right, you could still get some points, some partial credit, which where these FRQs, there's usually at least one part that you can do, right? And points are points. So even if you read an FRQ and you're like, that one's really hard, save that one for last, come back to it. But then when you come back to it, try your best to at least write something, right? And then at least you can maybe get some points, right? There's probably something. If you've done what you're supposed to do in this course, there's probably at least something of each FRQ that you can do, right? Even if you don't know everything about every FRQ. Good for you. So in this one, now they're talking about CFCs. So they say the Montreal Protocol of 1987 provided a global framework to phase out chlorofluorocarbon production and use. Although the Montreal Protocol has led to a dramatic decrease in CFCs released in the atmosphere, stratospheric ozone destruction has decreased only slightly. And then they want you to explain the process by which CFCs lead to the destruction of the stratospheric ozone. And this is where, why we're going to talk about how losing CFCs is still not led to a rapid decrease in the destruction of stratospheric ozone, which is something that a lot of folks don't realize. Okay, so these are your chlorofluorocarbons. Okay, so when they react with UV, so you could say this in equation form, or you could just, in word form. They produce, they basically produce this chlorine radical here, right, which just has a negative charge. And then that chlorine radical, what happens with that guy is this chlorine reacts with ozone and produces ClO plus O2. And if you remember, O2, okay, if you remember from our previous slide, right, O2 can react to form oxygen or to form ozone, but then this ClO or this CCl2F can actually go ahead and form another chlorine radical, which then break up more ozone, or this one, they can actually react and reduce more, or not form ozone, but like break up ozone. And so then it's basically, it's like a chain reaction. It just keeps happening, right? So there's a couple of reasons why the CFC, rapidly reducing CFC emissions has not reduced the destruction of ozone. And the reason is, there's a few reasons. CFCs are actually pretty slow to migrate into the stratosphere. So they don't just like immediately end up in the stratosphere. It takes them a while to get up that high. And so even if we were to like reduce CFCs, let's say today, right, the CFCs that were released today will take a while to make it to the stratosphere. And so it's not like whatever's there today is done. There's still gonna kind of mingle up there. And then these products have a really high lifetime, and in the atmosphere, especially the chlorine. So the chlorine just stays up there for a really, really long time, which is, not great when you're something that continually causes a chain reaction that breaks up the atmosphere or the ozone layer. And then we're also releasing other ozone depleting substances. Okay, so all of that is really causing that issue. Okay, so that's those are some of the main reasons, and a big one is 1 and 2 are really the main reasons, but 3 is kind of a little, so they give you credit for it. Okay, now what is an human activity that leads to the formation of tropospheric ozone, right? So that's the bad kind that is down where we live. Okay, so that's one of the ones that we don't like, or that's the type of ozone we don't like, right? Well, we've previously been talking about ozone that we do like. So what is something that leads to the formation of tropospheric ozone? Like, what's an activity? I'll give you like maybe 30 seconds or a minute to see if you can come up with one. Anything that forms tropospheric ozone. Okay, any type of burning fossil fuels. So like, for example, like cars, factories, energy plants, stuff like that. All of that stuff will form tropospheric ozone. Okay. Another thing that releases tropospheric ozone, just so you've got both of them in case you want it, is releasing VOCs, volatile organic compounds. Okay, so both of those will give you credit for that part. And since it only wants you to identify, you don't have to say what about it, you just have to say that it does. Okay, you don't have to like come up with some really great explanation. Okay, but then the next part they do ask you to explain. So then you're going to actually have to, talk about something. So the second part says, explain why tropospheric ozone peaks in the daytime. Okay, and we've talked about this a little bit in this course. I know I've seen you guys talk about it a little bit in discussions, and I think we talked about it last week. So what is it about daytime that makes tropospheric ozone form? So tropospheric ozone peaks in the daytime because sunlight, it's what they call a photochemical reaction. Yes, exactly. And it requires sunlight to proceed. Okay, so tropospheric ozone requires sunlight to be created. So that's why they consider it a secondary pollutant, because it's not actually released, but things that are released from burning fossil fuels then react with sunlight to make ozone, and so that they consider it a secondary pollutant. Okay, and then I think this question had one more part. Yes. Okay, so they want you to identify. Okay. They want an ecological impact, and then they want you to so you don't actually, since they ask you to identify, you don't have to explain it. You just have to identify it. You just have to, what is something that is a negative ecological impact with tropospheric ozone, and then a negative health impact. That's a perfect health impact. So for like since you did the health one, I'll do the ecological. We could talk about how it damages plant tissue. It inhibits photosynthesis. And it can, so not only does it irritate us, right, our respiratory system or our eyes, but it can irritate other animals. Okay, and then it says it does say where'd it go? It does say that you could talk about whoa, oh dear. Okay, so let me write that back in case anybody watching the recording needs it. Okay, so plant tissues, photosynthesis, okay, and then yeah, okay, and then we talked about irritating the eyes, right? Okay, it can also affect your respiratory system, just like it can other animals. And then you can basically, what I was getting ready to say before I deleted it, is that you can mention that it is a greenhouse gas and it contributes to global warming, but you'd have to explain. You can't just say global warming. You'd have to explain like how, for example, global warming would cause more mosquitoes to be around, which could cause us to get more mosquito-borne illnesses, and that would hurt our health. You could say something like that, but you couldn't just say like global warming, because global warming doesn't directly hurt your health. You'd have to explain why. So that's so you could put that as a choice, but you'd have to explain why.